ready to start. It's interesting. 4.6. So 4.6 is about starting to take everything that we've learned in chapter 4, and we're really starting to formalize these relations even more so. Now we're formalizing these relations and trying to determine, is the equation or is the solution set that we actually have a function? Because we've talked about, like, we have equations and that and functions, and I said at the very beginning of this chapter that, well, not every equation is a function. There's certain parameters that it must meet, and today we're going to really start to learn about that. Okay, so again, for all functions, there is a relationship that happens between our x's, the independent variable, and our y's, the dependent variable. For each domain of x, which means so each value of x, there's a unique range or a unique y. And when we see these in the mapping diagrams coming up, we're going to notice that for each domain that we have, each x is only going to map over to the y's one time. Let's see how this works as we set up these mapping diagrams. A mapping diagram is a way to visually show all of the possible solution sets that they currently give us. So look, here's our solution sets, meaning we have a bunch of the solutions that make up this function. We think it's a function. We're getting ready to test it to make sure. And here's the first equation. So not equation, I mean ordered pair. Here's our first ordered pair, and it's 0, 1. So the x coordinate here, the x coordinate is 0 and the y coordinate is 1. So the domain, we learned that domains mean our x's. Range means there are y's. The x is 0 and the y is 1. And then we have what? All of our x's. Let's just list a bunch of them. Here's -2. And we have what, a +2. And we have a +3, and we were very careful not to duplicate any. If for any chance there would have been 2 2's, we don't duplicate 2's. We only write them one time. Now let's look at our y's. Okay, we already have 1. We have 7. We have a 10. And another 7. Oh, I'm not going to duplicate the 7 because these 7's are twice. Now what we had said before, mapping diagrams. We need to map. We're going to like draw a line. This is going to map over from the x's to the y's. Well, it goes from 0 to 1. It's mapping from 0 to 1. And then we look at the next number, -2. Well, -2 mapped from -2 over to 7. And we had a +2. Okay, that's this coordinate where x is 2. It mapped from 2 to 7. And then we had a 3. The x, where x is 3, its y coordinate is 10. So it mapped from 3 to 10. Now, in order to look at this, to see if this is actually a function or not, we're looking at the domain. And we're looking for each number that's represented in this domain is only allowed to map over to the y or to the range one time. So look, this only maps over once. This only maps over once. And again, it doesn't matter what it's going to. Doesn't matter here. This is the side that matters. You have the x0 is going to one number here. The -2 is going to one number. Notice only one number is leaving. It's only leaving once. Then you have this one. 2 goes to 7. I know it goes to 7 twice. That's okay. This is the side that's important. 3 goes to 10. Notice from the bubble on the left-hand side of this mapping diagram, there is no V's leaving this bubble, meaning like 3 doesn't go to 2 different numbers. So notice how each one only goes or maps to one individual number in the range. So this, yes, this is a function. None of the x's repeat. Notice here we look here in a mapping diagram, you're looking at this, okay, and look, Each one is mapping one time. It leaves once from the domain. It leaves only one time from the domain. It leaves one time from the domain. If they give you a solution set, your goal is here. You want to look at the x's. Do any of these x's repeat? Right? Do any of the x's repeat? No, they do not repeat. So therefore, that is not going to be, it's perfectly fine. There's nothing being repeated. There is not going to be a single one of these domains that cross over more than once. So it is not going to violate this rule for us. So we know beyond a shadow of a doubt that this will be a function. So whether they give it to you as a set of solutions, or they either give you a mapping diagram or they have you create a mapping diagram, you can then determine if it is a function or if it is not. I'm going to pose this question to you. Look at the same set, okay? Let's look at the same set. What if we were to, they gave us this instruction, right? They said reverse your x's and y's. Is it a function? We like to ask this question on our standardized district tests. So we got to be careful, right? Let's take a look. We're going to erase some of this stuff that we put on, right? So now all of a sudden they told us to reverse our x's and y's, reverse our x's and y's. So that means that if it was an x, like these were x's, these are now going to become my y's, and these would be my x's. I know it seems weird, but they'll ask this. I promise you, they're going to ask you this question. Here's a set of ordered pairs. If they were to reverse the x's and y's, is it a function? So this time we look at the new sets of x's. Are any of them duplicated? Yes. Right here. So now, if they asked you for this particular set, if you reverse them, would this be a function? No, it's definitely not. So be careful. This is like a twofold question here. We got it one way. We took those sets, we put it in a mapping diagram. We checked it. Now each x goes only one time. Then we looked the way they were originally written. Great. It's definitely a function. But then if they add us up and they change this rule, hey, reverse your x's and y's. Is it still a function? Absolutely not, because that would mean that you'd have something repeating. All right, let's do this one here again. I want you guys pause the video. You guys try it. Let's see what happens. All right, we're back. First thing I can tell you is, let's see this. We're supposed to see if this solution set using a mapping diagram is a function or not. Again, our main goal is we're looking here at all these x's. Do any of our x's duplicate? I can see it duplicates. I already know this isn't going to be a function. This will not be a function. But let's see what it looks like in a mapping diagram. Okay, here's this. The first pair is 1. And then we have what, a -2. We have a 3. Oh, there's 0 again, so we don't have to put that 0 in twice. Let's see. Okay, this one here is a 2. We have another 2. Oh, and I don't have to write the 2 twice. We have a 3 and a 1. And let's draw our lines, right? 0, 1. It maps from 0 to 1. And then -2, 3. -2 maps to 3. Okay, so far it's looking good. Where are we going to falter? 3 maps to 2. Great. And 0 maps to 2. So this is, notice this mapping diagram. This is what it looks like when a mapping diagram is not a function. You end up having this V, oops. You end up having this V that leaves this left-hand side, the domain bubble. And so you have to be really careful about this, okay? And again, if you were to say this here, if they said, hey, reverse your x's and y's, look, if these were now to become the x's, again, it's still not a function because your x's are going to duplicate. So be careful, all right? You got to be careful when they ask us those crazy questions. So one way that we have to make sure that something is a function, x's can never repeat. If any of your x's ever repeat, it's not a function. What happens if they don't give it to us like this with the sets of solutions or a bunch of ordered pairs, or they're already represented in a mapping diagram? What if they only give us a graph? How can I tell if this is going to be a function or not? Well, we have this thing that's called the vertical line test. So a vertical line, a line that goes nice up and down like this. As good as I can draw that, right? Vertical line. Here's a vertical line, and you notice when you draw the vertical line, it only crosses this graph one time. It doesn't matter where you draw it. It's only touching the line once. What about this one? So yeah, this would be, it passes a vertical line test. It only touches the vertical line once. Only the vertical one time. Notice on this one here, if we were to go through and draw a vertical line here, it touches 2 times. Here, it touches 2 times. Here, that would be 1, 2, 3, 4. 4 times. This is not a function because it does not pass the vertical line test. You can draw a vertical line anywhere on this graph, and it can cross more than once. It is not a vertical line. And our last little question we're going to have here is they're wanting us to be able to draw a graph from a word problem and then determine, is that graph going to be a function or not a function? Okay, the weight of a dump truck depends on how many pounds of dirt it hauls. The truck is 12,000 pounds, and each, let's say this, I'm going to call this bucket. Doesn't like anything I'm doing there. Each bucket of dirt is 9 pounds. Okay, they want to know what is the function W of P equals 12,000, that's the weight of the truck, plus 9 pounds, and P must represent the bucket. Graph and determine if the relation is a function. All right, so I guess what we're going to need to start off with first is a little T-chart, right? And of course, we'll have a ref estimate here. Okay, pounds. This is the buckets, the number of buckets of dirt, right? Number of buckets. And this is the weight, LBS. And wow, this is starting pretty high, right? Because even if we don't put any buckets, our truck still weighs like 10,000 pounds. That's a heavy truck. So let's start doing this by we'll do these by 10K. 15K, 20, 25. Right, and as we go through here and we start to do this, we start looking, right? Okay, what if the truck weighs nothing? There's no buckets on it. Well, if you plug a 0 in here, we end up with 12,000. And what happens if we plug a 1 in here? We end up with 12,009. If we plug 2, 2 times 9 is 18. We have 12,018. And of course, it continues and continues and continues. This number's grown by 9 each time. Remember, we just talked about this in our other lesson. Every time this increases by 1, our y's are increasing by 1. So 1 bucket, 2 bucket. This is really an off graph, but we probably should have picked much bigger numbers to plug in for people. We were trying to make it easy on ourselves, right? Here's 10,000. And 2 would be like barely any change. Right? I mean, this is forming a line. It also, take a look at this equation. Y equals mx plus b. That is a linear equation for sure. Okay, so yes, we know that if we were to fully graph this out, maybe pick better numbers. If we were wanting to pick big numbers, this would all definitely work out. All right, go ahead, get started on that homework, guys, and try to get this stuff done. Functions aren't bad. We just have to be able to figure out, is it a function or is it not a function? Have a great day.